are making sure that every project that we work on will have a positive impact on all the community around us and also the world we live in. MQDC has a target that all projects has to meet LEED Gold standard. We introduced BIM into Thailand, into Bangkok. Wisdom 101 is one of the key projects. At this point, all the as-built drawing came from Revit model. Hopefully, this project will help Thai construction to move from 2D to 3D. Our design review we use now with work to navigate throughout the design. For example, it helps us to validate all the code requirements so we can walk through all the spaces. It also reduces a lot of change order, reduce a lot of waste material, and also cost and time have been reduced. We're able to cut off 2 years of construction by 6 months. We can build one building within 1.5 years throughout the use of BIM, Revit, now with work all together during design coordination throughout the construction process. With using the advanced steel technology with Autodesk, we were able to reduce a lot of material from steel. For Wisdom 101, we were able to reduce the use of energy by 30%, the use of water by 40%. We able to put in a green space. We also able to reduce CO2 by 50,000 tons per year. We are making sure that the community around us will gain benefit directly from us being there.
Technology and sustainability are one for me, and I cannot imagine doing a green building without being able to measure it and simulate things. My name is Joseph Corey. I'm an architect from Geotectura Studio. We are using cutting-edge technology in order to achieve the goals of being sustainable. Revit is the platform we are using in order to make the best product that we can deliver, that will be energy efficient, will be easy to maintain, and will be a great place for people to study or to live. We had a very complex geometry in the Porter School of Environmental Studies. So we took all the data from our modeling straight to the manufacturer. We use Revit not just for the architectural modeling, also for the mechanical ventilation modeling. We couldn't have done this without using the right software in the right time. On a BIM model, I can get a very good feedback of the energy efficiency of the building that I am doing, and having all this information available for us and for the consultants. This is the right direction. This is the right tool. Using the AC collection, we can do more, and we can be more efficient, and we can deliver it more quickly. So it helps me to be competitive in the architectural market. It's not ethical for an architect or any designer in our age to do and design things that are not sustainable.
This video will show you how to create a 3D building information model using a point cloud processed in ReCap, modeled in Revit, and coordinated in Navisworks. To start off, let's bring together a point cloud captured with the Leica BLK360 imaging laser scanner and a point cloud created from photos from an aerial drone. We'll register them together in ReCap. If we go into Real View mode, we can take measurements, add comments, and share the project with everyone involved. Next, we need to clean up the point cloud and prepare it to be used in Revit. There are tools we can use to quickly select objects like an entire floor at once. Once it's selected, we can tag it, put it in a group called a region, and hide it. Now, we'll do the same thing with the ceiling. Let's quickly select all of the points that make up the ceiling, put them in a region, and turn them off. If you want to clean up points that aren't relevant to your project, like this ladder, you can delete them. Here, we're creating a section view to help us make a 2D floor plan in Revit. We'll bring the point cloud into Revit, where we can use it to produce either a 3D model or a 2D floor plan. Let's look at the elevation view of the entire point cloud and add in elevation notations. These are notes architects typically add in the design phase to indicate the floor-to-ceiling or floor-to-floor heights. Let's change the points to a single color. This will make it easier for us to see the section of the point cloud. Now we'll add some dimension notes for our floor plan drawing with the dimensions that we want to highlight for this project. Back in the elevation view, we've created some Revit window objects by tracing them from the point cloud. Now we'll just copy them in the elevation view for the rest of the building. The grid line numbering scheme is another note often added in the design phase of a project. Since we've got the columns in the cross-section view of the point cloud, it's easy to place the grid line annotations. In many Autodesk products, you can import point clouds from Recap into the design tools where you're creating 3D BIMs, floor plans, and so on. You get seamless and consistent interoperability across Autodesk products, supported by Recap technology. Here in Navisworks, you can also bring in the Revit BIM together with the 3D point cloud. Then, in Recap, you can import the Navisworks model back into the full point cloud, where you can overlay the model with the photos that were taken for the scan project. So now, you've got the real-world images combined with the 3D geometry from Revit. Using this combination of model and point cloud project, you can create some pretty interesting 3D visualizations to help with staging your projects or for quick snapshots. It's also possible to get an augmented reality-like view of your projects. You can export the images from Recap or even make videos in Recap using these visualizations. We'll bring in the Navisworks model, which was created in Revit. Back in Recap, again, you can see the visualization when you combine the imagery from the point cloud project with a 3D model. Recap, Revit, Navisworks, and a range of other tools are all available through the Autodesk AEC collection.